Welcome back. Try not to speed through this, just 30 seconds. Let yourself settle in. Welcome back. All right, so digging into more of the endocrine system today. All right, so endocrine system. It's where we've been for a while now. So we're going to kind of bring some things together, talk a little bit more about negative feedback, and then discuss positive feedback and talk about endocrine pathologies. The endocrine system is one of the primary places where we see this positive-negative feedback system that maintains homeostasis. We talked quite a bit about negative feedback. So first I'm going to introduce positive feedback, which is probably something that you're familiar with, probably something that you've seen before in other classes. Well, unlike negative feedback, in the case of positive feedback, the input acts to increase the action rather than decrease the action, or increase the hormone input if we're talking about endocrine systems specifically. The sort of the most common example that you see of positive feedback is childbirth. And so when a baby is growing in the uterus, you'll sometimes hear the term that the baby drops. And what happens is when a baby quote unquote drops is the baby's head puts pressure on the cervix, and you get, I'm going to use a different color here, you get cervical stretch. So the cervix is the opening between the vagina and the uterus. It's kind of like the protective doorway, and we'll talk about that more when we get into the reproductive system. So the cervix, this opening, this supramuscular tube, is experiencing pressure from the baby's head, and it starts to stretch. And when the cervix starts to stretch, what that does is it stimulates the body to release the hormone oxytocin. This may be a hormone you've heard of before. Oxytocin is really, really important in childbirth. It's also important in bonding. It's important in lactation. So cervical stretch sends signals, which we'll talk about in more detail later, to release oxytocin. The release of oxytocin then, what this does is this causes the uterus to contract. So you may remember the uterus is the muscular organ that the baby is growing inside of. So the baby's in the uterus. The uterus is that muscular organ, and then the cervix is the tube that leads from the uterus to the vagina. So let me draw that so that we can make sure that that makes sense. What's a good color to draw that in? Let's do this. Let's do this. Okay. So this is going to be my super, super awesome technical drawing of the uterus. So here's the uterus. Baby's in the uterus. then there's a muscular tube right here, the cervix. And then the opening here is the vagina. So uterus, cervix, vagina. And we'll go over all of this in more detail when we get to the reproductive system. But as the baby, let me think, can I draw this in a way that isn't going to look really, really awful? The baby's head is right here. And it does actually kind of look a little bit like an alien sometimes, like that. Body is kind of here. And they're way cuter than my little worm drawing. And the head pushes on the cervix. That stimulates oxytocin. Oxytocin release causes uterine contractions. So if the uterus then contracts, so it's the uterus is this crazy, amazing muscular organ, like wildly muscular. And so if the uterus then contracts, what's it doing? What does contraction do? It's going to cause the uterus to get smaller. Right? Like my fist. Contraction. And when the uterus contracts, then that's going to push on the baby inside the uterus. Okay? So pushes the baby. Uterine contractions, going to push the baby, and the baby only has one direction to go. So it pushes the baby against the cervix. We push the baby against the cervix. What does that cause? Oh, didn't mean to make that go away. That goes, whoop, more cervical stretch. So you can see that this loop just feeds back into itself, feeds back into itself, feeds back into itself, feeds back into itself, feeds back into itself. So this is positive feedback because each step in this loop causes an increase. It causes another step in the loop. So it doesn't cause the loop to stop. It causes the loop to intensify. Okay, so how do we make it stop? Because eventually it stops, right? Well, the way that we make it stop is something outside of the loop happens. And what happens is that at some point along the way, one of these uterine contractions causes what to happen? The baby's born. So the baby exits the uterus. I suddenly forgot how to spell uterus. The baby exits the uterus. If the baby exits the uterus, then those contractions don't push the baby against the cervix. And so what happens is by the baby exiting the uterus, the cervical stretch stops. And that's how we exit a positive feedback loop, is something outside of the loop stops the loop. Okay, so childbirth, really the most famous positive feedback loop. Another one is blood clotting. And we'll talk about that when we get to our whole section on blood. So the concept here is that positive feedback, the elements inside the positive feedback loop continue to increase the positive feedback loop. Much of our focus up till now has been on negative feedback. And this is the primary way homeostasis is maintained, is through negative feedback. We've had lots of different examples of negative feedback. So the one that I'm going to walk us through when discussing the elements of negative feedback is regulating blood calcium levels. So we get if we're going to have a negative feedback situation happen, we start with some sort of stimulus. So in this case, our stimulus is going to be, will that show up? It's going to be low calcium. So out in the blood plasma, the circulating action, systems detect that there's not enough calcium circulating in the blood. And that calcium may not seem like a super important thing, but hopefully by the end of this class, you'll understand how critically important calcium is to kind of everything. And if not, then I really didn't do my job well. So, low plasma calcium. That's detected by a parathyroid cell. Specialized cells, they detect low plasma calcium. Parathyroid cells then release, you guessed it, parathyroid hormone, and I'm going to put that in a little circle. Now we release, in response to low calcium, parathyroid cell releases parathyroid hormone. I didn't make my little purple circle big enough. Releases parathyroid hormone. This is a hormone, so stop and think for a second. Where does that get released? Is it paracrine? Is it autocrine? What happens? I'm gonna make a little question mark here. Where does that get released if it's a hormone? Okay, parathyroid hormone gets released to answer your burning question that I know you were super excited about. Of course, it's a hormone. It has to get released into the bloodstream. Parathyroid hormone is released into the bloodstream. Then it has to travel far away because it's a hormone. That's a characteristic of a hormone. And it goes to a couple of places. It goes to the bones. This is my super cool bone drawing. So parathyroid hormone then goes to the bones. And it also goes, let's see if I can pull off, I don't think I have the right colors for this. This one will work better. And then it also goes to these guys, the kidneys. Parathyroid hormone goes to the bones and the kidneys. So if parathyroid is going to go and cause the bones and the kidneys to do something, what do the bones and the kidneys have to have in order for parathyroid hormone to be able to do that effectively? So parathyroid hormone is going to go cause an effect at the bones and the kidneys. So what do these have? What do the bones and the kidneys have? Okay, hopefully you thought, well, they have to have the correct receptors, right? We have any chemical messenger, we have to have the key and the lock. The only places that are going to react to our chemical messengers, whether they're paracrine, autocrine, hormone, neurotransmitters, neurohormones, it has to have the proper receptor. So the bones and the kidneys have receptors for parathyroid hormone. So what's going to happen whenever the parathyroid hormone binds with the receptors at the bones and the kidneys is that, I have to make that go away. At the bones are going to experience something called, let's see if I'll make this, resorption, which is kind of a weird word. Resorption. And so we tend to think of our bones as just that their entire job is to hold us up and to be fulcrums for muscle movement. And that is a critically important job. But bones are also a storage site for calcium. And so whenever our blood calcium level is too low, parathyroid hormone signals the bones to release calcium. And so what happens is that calcium stored in our bones then gets released into the bloodstream. And if this happens too much, it can lead to a condition called osteoporosis, which you may have heard of before. Okay, the kidneys then are going to start absorbing more calcium. Oh, sorry. I should not have used the word absorbing. That will be confusing later when we talk about the kidneys. I'm going to use the correct terminology. Okay, resorption. Resorption is the right word. So they're going to also start resorbing calcium. So as your blood is filtered by the kidneys, they let a lot of stuff go in urine if you don't need it. If your blood calcium is too low, then the kidneys are going to start pulling more and more and more calcium out of that filtrate and dumping it back into the blood. And you'll see more of that when we get to urinary. Another thing that is going to happen at the level of the kidneys is that the kidneys are going to start producing something called calcitriol. They produce calcitriol, and what this does is this leads to intestinal increased intestinal absorption of calcium. So calcitriol then gets released into the bloodstream. Boom, it goes over here to your intestines. Okay. Twisty turny action happening over here in your intestines, where in your small intestine where primary nutrient absorption happens. And so this is where absorption is the right word. Of calcium. Okay, so the reason that absorption is the right word here over in the intestines is because here the calcium is coming from an outside source. The calcium is coming from the food. And so what calcitriol does is it signals the intestines to pull in more calcium, as much calcium as they possibly can, from the food that's passing through the intestines, and not let that pass through into the feces. So it's being absorbed. It's coming for the first time into the body. The reason that here in the bones and in the kidneys the term is resorption is because it's already part of the body, and now it's being pulled back into the blood. So that's why those two terms are a little bit different. Okay, cool. All that's happening, great. So the bones are being resorbed. They're dumping more calcium into the blood. The kidneys are pulling more calcium out of the filtrate, dumping that into the blood. The intestines are pulling more calcium out of the food, dumping that into the blood. So what does that do to that plasma calcium level? Well, remember up here, our first signal, the first reason that this whole system started was that we had low plasma calcium. So when all of this calcium is getting dumped into the blood from all these different sources, the result is that now, awesome, we get an increase in plasma calcium. Sweet. What that does, we get an increase in plasma calcium. This is where our negative feedback comes into play. Increase in plasma calcium, that feeds back way up here to the first sort of detector. It feeds back to the parathyroid and tells the parathyroid, okay, stop releasing parathyroid hormone. We're cool. We have enough calcium in the blood now. So then this is negative feedback. Okay, so based on what we've already learned, what I'd like you to think about now, so we established that this is negative feedback. what kind of negative feedback is this? So we've talked about 3 different types. We've talked about long loop negative feedback, short loop negative feedback, and ultra short loop negative feedback. So what type, this example that I've just given you, what type of negative feedback is this? Cool. Let's see, where are we on time? Ooh, 20 minutes. All right, we're gonna stop there. Give you a break to exercise your Pomodoro technique, grab a snack, do whatever it is you need to do, and we'll come back here and talk about endocrine pathologies.